Good morning and Jai Hind all of you. So grade 12 students, in this unit we have studied about basically atomic structure, various atomic models starting from Democritus, then Dalton, uh, then Thomson, and then Rutherford, and lastly Bohr. So in the end we also studied about Rutherford's gold foil experiment, his conclusions, the various terms related to it like impact parameter, distance of closest approach, etc. So with this we are now able to read about the composition of nucleus. So I will tell you now about the composition of nucleus. So we are now familiar with this that nucleus is a very small portion inside the atom where basically protons and neutrons are present, and electrons revolve around the nucleus in a fixed orbitals of fixed energy. So these assumptions were given by the Bohr atomic model. So now every atomic nucleus except that of hydrogen has two types of particle. First are protons and next are the neutrons. Proton is a fundamental particle. It has a positive charge of 1.6 into 10 raised to power minus 19 coulomb, and its mass is 1.67 into 10 raised to power minus 27 kg. So this is the mass of the proton and this is the positive charge that it contains. It is approximately 1836 times heavier than an electron. Similarly, neutron is a fundamental particle which is having 0, or I can say it is a neutral particle with the mass 1.675 into 10 raised to power minus 27 kg. It is approximately 1840 times heavier than an electron. So I can say in the nucleus proton with the positive charge and mass, and a neutron with the 0 charge and mass are present. So most of the mass and positive charge of the atom is concentrated in the very small portion, and that portion is called nucleus. Atomic number. What is atomic number? Number of protons in an nucleus. In a nucleus of an atom is called atomic number. As we know, atom as a whole is neutral, so we can also say the number of proton or number of electrons in an atom. It is denoted by Z. The sum of number of protons and number of neutrons in a nucleus of an atom is called atomic mass number. It is equal to number of protons plus number of neutrons. So it as a number protons and neutrons contain mass, so it is also called atomic mass number. So it is the number which indicate the mass of the atom, so it is called atomic mass number. It is denoted by capital A. Atomic mass unit. What is atomic mass unit? It is also called AMU. Atomic mass unit is the 1/12 of mass of one atom of carbon. So what is the mass of carbon atom? 12 over Avogadro's number is 6.0 6.023 into 10 raised to power 23. With this we can calculate the value of 1 AMU, that is 1.66 into 10 raised to power minus 27 kg. So this is the value of AMU in kilograms. So now with this we will now study about size of a nucleus. Nucleus does not have a sharp or well-defined boundary. It has very cloudy boundary. However, radius of nucleus can be given by the formula. So this is the basic formula. R directly proportional to cube root of atomic mass number. By removing the proportionality, we equalize the formula by inserting a constant here, that is R naught, where R naught contains the value 1.2 into 10 raised power minus 5 meter. It is a constant which is same for all the atomic nuclei. Radius of a nucleus ranges from 1 Fermi to 10 Fermi. As we know, 1 Fermi is 10 raised power minus 15 meter. Nuclear volume. What is the volume of a sphere? We recognize the nucleus of atom and resemble it with the sphere. So what is the volume of a sphere? That is 4 by 3 pi r cube. So putting the value of r here, we got 4 by 3 pi r naught cube a. As we know, 4 by 3 is a constant, pi is a constant, r naught is again a constant. So the volume of the sphere, volume of the nucleus depends upon its only one quantity, that is atomic mass number. Now nuclear density. Nuclear density is the mass of nucleus. Mass of nucleus, that is m equals to amu. AMU value is 1.66 into 10 raised power minus 27 kg and volume is this. So putting the values of pi r naught here, we got this. So nuclear density is equals to rho equals to mass upon volume. Putting the values of m and v here, we got a constant term, that is 2.29 into 10 raised power 17 kg per meter cube. So with this we conclude our discussion as nuclear density does not depend upon mass number, as it comes a constant, there comes a constant quantity. So all the nucleus have nearly the same density. Second is the nuclear density has extremely large values. Such high densities are found in white dwarf stars, which contain many nuclear matter. So its density is very large. Third one is nuclear density is not uniform throughout the nucleus. It has a maximum value at the center and decreases gradually as we move from center to the away from the nucleus. Fourth one is nuclear radius is the distance from the center of nucleus at which density of the nuclear matter decreases to 1/2 of its maximum value at the center. So it is the distance of center of nucleus to the point where its density reduces 1/2 from its value at center. So hopefully you have understood all the terms related to composition of a nucleus, atomic mass number, atomic number, density. So I will give you question related to this topic also. So if you have any doubt, you can ask me, and you can message me personally or you may comment in the inbox also. Thank you so much.